Hey guys, today we have a portable power station from Pecron. This is the F3000LFP. This model features a 3072 watt-hour lithium iron phosphate battery combined with a 3600 watt continuous inverter. Guys, this is selling for less than $800. That is significantly cheaper than competing brands with similar ratings. Let's take a look at what this thing can do, and then if we have time, we'll tear it apart and see what's inside. This is a very nice power station with a wide array of connection options. We have 5 outlets that will accommodate 20 amp plugs. We have a single 30 amp receptacle. It's a NEMA TT-30R. This would be a very easy way to wire this to a small breaker panel. We have an AC input capable of charging at 1800 watts. We also have an XT60 connector for connecting our solar panels. This will accept anywhere from 25 to 120 volts at up to 25 amps for a max charge rate of 1600 watts. On the DC side, we have a 12 volt 10 amp car accessory port. There are two 12 volt 5 amp DC barrel jacks, a 100 watt USB-C, an 18 watt USB-C, and two 18 watt USB-As. We have our main power button with separate buttons for controlling the AC and DC outputs respectively. I feel like this covers nearly every connection option I could possibly want, and I like that they're all right here on the front of the unit. Lastly, we have an XT120 connector here on the right side for an expansion battery, and this connector is actually really cool. They sell expansion batteries which I feel are very reasonably priced, but there's a separate cable you can purchase that allows you to pull native battery voltage from that port. This is a 51.2 volt battery or a standard 16S configuration. Can I connect any old 51.2 volt 100 amp hour rack battery to this to expand the capacity? Will that work? Maybe that's something we'll look into further in a follow-up video. At 63 pounds, this power station has quite a bit of weight to it, but it's light enough that one person can easily move it around. Included with this power station is the AC charging cable containing 14 gauge conductors. And they also included the MC4 to XT60 adapter cable so you can plug in standard solar panels. You hear that, EcoFlow? They included the MC4 adapter cable. Let's go ahead and plug this in and prepare for our capacity test. AC power's in, and we're charging at 1753 watts, and it's estimating 1.2 hours until it's completed. For the capacity test, I ran an 860 watt load, which is approximately a 0.28 C rate. I left it run until the power station shut off, and the resulting capacity was 2,863 watt hours. That is actually quite impressive. Most of the portable power stations I've been testing are averaging around 85% efficiency after the inverter losses. This one's sitting at 93%. So I have an array of SEG panels. These are 305 watt panels, 40 volts open circuit each. I have two wired in series for a total of 610 watts and 80 volts open circuit. So I've got my XT60 adapter connected here and I'm ready to plug it into the power station. And we're going into the input port. Alright, so it recognized that an input was plugged in here, but it's saying 0 watts. So let's give it a minute to start charging maybe. Oh, there it goes. 179, 333. Alright, it looks like we're holding steady in the 360 watt range. Now, two of these in series is 610 watts. However, we are in winter and the solar panels are facing west. It certainly is not an optimal angle. So that is pretty good in my opinion. Again, you could connect up to 120 volts at 25 amps here to get quite a bit more wattage. There are several settings you can change on here and it does not require an app to use. To access those settings, you want your power station turned off, then press and hold the DC button for 8 seconds. You'll see it turns on and enters in the setting mode. So for example, the first setting we see here is the charge rate, which by default is set to 100%. If you want to adjust the percentage, you simply press the DC button to select the desired preset option. I'm going to leave mine set at 100%. To navigate to the next option, you can press the AC button. So now we're on setting 2, which is the auto shutdown timer. Once you're done, you can simply press the power button to save those settings and exit. Let's take a look inside the case here. Right on top you can see two large heat sinks that stand out. This is our main inverter board here. We've got fans on each side that move air across those heat sinks. It looks like almost everything is modular on this front display panel. So here's where our PV comes in directly down to the main board there. These two connectors right here is where our battery voltage is coming in. And those are spliced off to this lead here. It looks to be an XT30 is bringing battery voltage directly to this front display. Looks like we got some cylindrical cells down there. Quick look at the back of the display board. We have our AC input here on the right. We have our 30 amp output receptacle. And we have our 20 amp receptacles on the bottom here. The grounds are all bonded together, so we have the input ground, then we have the output 30 amp directly to the output 20 amp receptacles. Again, all bonded together. That's perfect. That's what we want to see. This is our DC charging output here, and it appears this odd formation of standing transistors, standing FETs here. This is the input XT60. It's going through these, and then it's going to the output XT60. Moving to the center of the board here, this is our Wi-Fi module here. They utilized an XT60 for the AC output. Not sure if you can see that or not, but these cells are part number CMC-BR32140SE15E, and they are 15 amp hour cells. They appear to be CHAM brand, C-H-A-M, not a brand I've heard of before, so I can't really comment on them. I do see they have a temperature sensor stuck directly to the side of one of the cells here. This must be the BMS. Underneath the inverter, we have a little sticker describing our battery here. Again, these are 32-140 cells. We already established that. 16S4P. So there are 4 cells wired in parallel. That gives us our 60 amp hours. 16 in series gives us 51.2 volts nominal. We can get a close-up look at our laser welds there. They are very clean and consistent. And we can see on the positive end there, they did use a paper insulative disc, which I always like to see. I like having that extra layer of insulation between the cell and the nickel strip. This PCB is collecting the balance leads and taking them back to the central point here. So of particular interest here is how they're handling that battery expansion port and whether or not that goes through the BMS. So this board located right here is the board that the XT120 is connected to, and then this board right here is our BMS. So this connection point right here is combining the battery power off of the BMS with the battery power from the XB120 and then sending it to the inverter. That means the BMS is sitting between the battery pack and the XB120. That is good, especially if you're going to be using that to be drawing power. But that also means that the inverter is sitting after the XB120 port. So if the battery in this device shuts off and you have an expansion battery connected, this unit will continue to operate off of that expansion battery. So I believe everything's been put back together. Let's go ahead and give it a try real quick. Here we go. All right, looks good. Try our AC output. Everything's working. There are a few additional points to discuss. When using this as a UPS, the transfer time from grid to battery power could be up to 20 milliseconds. For that reason, I would not recommend using this as a UPS for a computer or a server. With computer equipment, we typically like to see transfer times of 10 milliseconds or less. Also, the XT120 cable for pulling battery from the side expansion port here is not available just yet. I did ask Pecron about this, and they expect it to be available in the middle of 2026. Now, it is a standard XT120 connector, and battery voltage is already live on the terminals, so I don't think it needs any sort of communications. You probably could go out and make your own cable. However, I'll be waiting for the release of the official cable from Pecron. There is one thing I don't like about this power station. That is the phone app. If you follow my videos, you know I'm not a big app person. I don't like having to install an app to manage every single device under the sun. First, you're required to create an account to use the app. Second, even though this power station has Bluetooth, you are required to connect this to the Wi-Fi in order to use the app. There is no way in the app setup process to bypass the Wi-Fi connection step. That is a big no for me. I don't see any reason why power stations or any devices like this need to be connected to the internet. None at all, especially when it has Bluetooth built in. Based on what I've seen here, I think this is a fantastic device to run those critical appliances in your home during a power outage. With a 3600 watt inverter, there's not much you can't run. You can run pretty much everything you need, whether it be a refrigerator, a microwave, a freezer. You can even run a space heater on this, but of course that would deplete the battery quite quickly, so I certainly would not recommend a space heater, but you could do it. There are plenty of connectivity options, and I love that it has 520 amp receptacles, reducing the need to connect, or pretty much eliminating the need to connect a power strip or other power splitter. And quite honestly, I don't know how they're selling this at $800 and still making a profit. It's a really good deal. Please let me know what you guys think. I'll leave a link down in the video description if you want to learn more about this power station, along with any coupon codes I can find. Please give this video a thumbs up before you go, and thanks for watching.